Following question was asked from theory of computation. The topic is regular languages and it is asked for 1 mark. The question is as follows. Let L1, L2 be two regular languages and L3 a language which is not regular. Which of the following statement is are always true? For this, we need to scan one by one. Option A, L1 equal to L2 if and only if L1 intersection L2 is equal to 5. So here this if and only if make it false. Because of this if and only if, because this may true, but if and only if this make it false, so it is not a true here. Thereafter L1 intersection L3 is not regular, so L1 intersection L3 is not regular because L3 is a language which is not regular and L1 is a language which is a regular. So what basically we are doing, we are making regular intersection with not regular. So it is not regular, thus option B is true. And option C, L3 bar is not regular. So if you see that we are having non-regular language, non-regular language, and the non-regular language ka complement is also not regular, right? Thus option C is also true. And option D is L1 is a regular, L2 is a regular. So the complement of L1 regular union L2 regular is not true because complement operation is not regular on that. Thus option B and option C are the correct answer for this particular question. I hope it is clear. The following question was asked from theory of computation and the topic is deterministic finite automata and it was asked for 2 mark. The question is as follows. Consider the 5-state DFA machine which is accepting the language LM which is a subset of the combination of 0 and 1 ka clean closure which is shown below. For any string which is like W belongs to the combination of 0 and 1 ka closure, let n0 W be the number of zeros in W and n1 W be the number of ones in W. Then which of the following statement is are false? They are asking which of the following statement is are false. So this is a DFA, deterministic finite automata, given with 5 steps and we need to perform minimization. So for performing minimization, as of now you can see state 1 is separated from all the other states. This is my step 1. Now in step 2, if you will see here, if I am going to perform it, on 0, on the basis of closure of 0, if we are going to perform on the basis of closure of 0, then state number 2 will be there and state number 5 will be there. That is 2 and 5 are 0 closure. 2 and 5 are 0 closure. And 3 and 4, this 3 and this 4 are 1 closure. So in step 2, the states will be separated like this: 2, 5 and 3, 4. Again, if you will try, then I will get the same. No further segregation are there in step 3. So we need to stop here because the previous step was same. Now here if you can see, state 2 and state 4 are clearly distinguishable. State 2 and state 4 are clearly distinguishable. So this statement A, it is a true. State 3 and 4 distinguishable in M. So 3 and 4 are not distinguishable. They are not distinguishable. They are a part of same. So it is false. Statement C, states 2 and 5 are distinguishable in M. So state 2 and 5 are also not distinguishable because they are also part of same state. Thus it is also false. And D option, any string in W with n not W equal to n1 and n1 equal to W is in LM. Basically, the machine itself is generating the equation by which we can say that number of zeros and number of ones will be equal in that string. Thus, it is true. Now, in our question, it is asked which of the following is are false. Thus, option B and C are false. Option B and C are false. I hope it is clear. The following question was asked from Theory of Computation and the topic is CFG, context free grammar. It was asked for 2 marks and the question is as follows. Let G equal to a set of V and summation S and P be a context free grammar in Chomsky's normal form, that is CNF, from which we can say that that summation is taking A, B and C, these 3 keywords, and V containing 10 variables, right? Now, including the starting symbol S, the string W, that is A ka power 30, B ka power 30 and C ka power 30 is derivable from S. The number of steps which is according to the application of rules in the derivation S derives star W is, right? So for CNF, for Chomsky's normal form, the number of steps required are 2 into W minus 1. The number of steps that is required is 2 into W minus 1. For example, you can understand it like this. For example, if S is deriving AA and A is deriving A and I require the string AA, then the string will derive like this. S derives AA, thereafter it will further derive AA and then I will have this particular string. So the number of steps derivable is 3 steps. Step 1, 2, 3, one by one. So here 3 steps are there, right? Now, here if you can see the summation of W, it is already given in the question that 30, 30, 30. So we will require 30 steps for generating this A, 30 steps for generating this B, and 30 steps for generating this C, because it will process one word at a time, one particular letter at a time. So it is nothing but 30 plus 30 plus 30, that is 90. Now just substitute the value 90 in the formula. 2 into 90 minus 1, that is 180 minus 1, and the final answer is 179. So 179 is the correct answer for this NAT type question which was asked in 2 marks for this. I hope it is clear. The following question was asked from Theory of Computation and the topic is regular expression. This was asked for 2 marks as a NAT based question. The question is as follows. Consider the following 2 regular expression over the alphabet 0 and 1, where R is 0 star plus 1 star and S is 0 into 1 ka star plus 1 into 0 star. The total number of strings of length which is less than or equal to 5, which is less than or equal to 5, which are neither in R nor in S, is how much? NAT based question. So we need to do this question step by step, right? So let's do this. Basically the question is as follows and I need to follow some steps. The number of strings of length which is less than or equal to 5. Okay, the number of strings of length less than or equal to 5, that is according to the condition on 0 and 1 is 2 ki power 0 plus 2 ki power 1 plus 2 ki power 2 plus 2 ki power 3 plus 2 ki power 4 plus 2 ki power 4, right? And plus uh, 5, right? So that is what we are having equal to 5. So 5 into 5 we need to add here, that is plus 25 equal to I am going to get that as a 60. Okay, 2 की power 5, that is 32. So it is nothing but 2 plus 4 plus 8 plus 16 plus 25, that is 63. Now, given that R is equal to 0 star plus 1 star, the strings in R of length which is less than or equal to 5, the strings in this particular example which are less than or equal to 5, so we need to calculate, and it could be like one string could be like epsilon, it will be considered. One string could be 0, other string could be 0 0, thereafter 0 0 0, thereafter 0 0 0 0, thereafter 0 0 0 and double 0, 5 length, not more than that, right? Now after that 1 1 1 1 1 1 1 1 1 1 and 1 1 1 1 1. So these are the strings that is possible on the given grammar of length equal to 5 or less than equal to 5, and these are total 11, right? After that, the next grammar is also given, because this we have solved using this, that is this part which is given in the question. Now we need to consider this s equal to 0 1 closer plus 1 0 closer. So using this s equal to 0 1 ka closer plus 1 into 0 ka closer, how many strings can be generated whose length is equal to 5 or less than 5, right? So for that we need to make a strings, so one could be 0, that is possible from here, right? 0, and thereafter if you will see 0 1, and thereafter if you will see 0 1 1, thereafter 0 1 1 1, and thereafter 0 4 times 1, as well as 1, and thereafter 1 0, and then 1 double 0, and then 1 triple 0, and then 1 5 times 0. So these strings are having length less than or equal to 5, and this total are 10. These are in number 10. Okay. Now total number of strings, if we are going to combine the R plus S, so here it was 11 and here it is 10, right? Now we need to check what strings are common in them. So if you can see, 0 is common among them, and 1 is also common among them. These two strings are common among them, so I need to subtract it. Ultimately I am going to get 19 here, correct? Now total possibilities were 63, and 19 strings are there whose length is less than or equal to 5. So if I am going to subtract, I am going to get 44. So this 44 number is the number of strings that can be possible using grammar R, using rule S, and which should be made by combination of 0 and 1 as per the question, which is having length less than or equal to 5, which is neither in R nor in S. So 44 is the correct NAT question. 44 is the correct answer for this question. I hope it is clear.